Hi everyone, and thanks for tuning in to our video on applications of systems of linear equations. So today we're going to be putting into practice the methods to solve a system of equations that we've been working on, but now we have more of a context to do that work in. So let's just take a look at example 1. Let's read it together. It says, the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. And the question is, how many children and how many adults attended? Now, oftentimes we go right to the algebra. Like, okay, we've been studying systems of equations. How do I set up a system of equations? But I actually want you to do the opposite. I want you to pretend you're not in an algebra class. You don't want to deal with X and Y. I want you to think this problem through more granny style. So let's just recall this again. 2,200 people enter the fair. That's the quantity of people at the fair. And $5,050 is collected. So 2,200 people come in. This is how much money's collected. And just remember, $1.50 for each kid, $4 for every adult. So pretty much anybody could do this problem with a little bit of guessing and checking. So I'm going to pull these notes off for a second, and I've set up kind of a template here to walk us through. So think about it. Even like an elementary school age student could do this. We just have to make sure that the number of kids that come into the fair added to the number of adults has to make 2,200, like that's one condition. And at the same time, simultaneously, if we have that number of kids, when we take that number of kids times $1.50 a pop and add it to the number of adults times $4 a pop, the total money then collected has to equal $5,050. So these are the conditions. So we just guess and check. So I don't know. How many kids do I think went to the fair? Let's say 1,000 kids go. Let's say 1,000 kids go to the fair. So that means the kids here is 1,000 and the kids here is 1,000. Now, if 1,000 kids go, then how many adults go? Well, we kind of have to go backwards here. 2,200 total minus 1,000 kids means that the number of adults would have to be 1,200 because these must add up here, which they do. So then if I throw that 1,200 over here, we have to check out the money. So I have to take 1,000 kids times $1.50 collected for each kid plus 1,200 adults times 400, or 4, not 400, my goodness. Okay, so let me do this money here. Let me turn my calculator on here, clear this out. So if I take $1.50 times 1,000 kids plus $4 times 1,200 adults, ta-da, up, that's 6,300, not 50-50. So this really gave me 6,300, and that's over the price of what we collected. So this is sort of a frown. That first attempt at guessing and checking did not work out. So we're back to the drawing board. Let's try it again. New template, same ideas set up, but we get to pick new numbers. So how many kids do we want? Well, I'm thinking, just hear me out here. Well, no, maybe there are more kids than adults, because if one adult brings 3 kids, yeah, let's go higher on the kids. Let's say, how about 1,300? Let's go up a little bit. Let's say 1,300 kids come. If I take 2,200 minus 1,300, that should give me my adults. 1,300. That means 900 adults came. So let's try that out. If I add those two together, it works out for the total people that came in that day. Now let's check out the money. So if 1,300 kids come in, 900 adults, let's see if this magic makes my total price. So I'm going to have to take $1.50, $1.50 for every 1,300 kids that came in, plus $4 for every 900 adults that came in. Ta-da! Ooh, 5,550. Hey, that's a better one. 5,550. So it came down from the 6,300, but it's still a frown because we're still not quite at that magical number of 50-50. So I could keep playing with this. Listen, if you've got a lot of time on your hands or don't want to deal with algebra, you can certainly keep guessing and checking. But I'm at the point now where I'm ready to introduce some algebra. And it's really simple, guys. Let's think about it. When we don't know a number, but we want to find it, we typically let a letter of the alphabet hold the place temporarily until we figure it out. So for the kids, I'm going to choose X to hold the place of the number of kids coming in. And for adults, I'm going to make it different. I'm going to call it Y. But I do know that X plus Y has got to make 2,200. At the same time, however many kids I have, I know I have to take $1.50 times that amount and add it to $4 times the number of adults. And altogether, that's going to make 50-50. So now watch how the algebra comes into action here. If I come back to my problem here, I just have to do a couple of things. Number one, I've got to let my reader know that, hey, X is holding the place for the number of kids attending the fair, and that my Y is going to hold the place for the number of adults. It's important that you let your reader know that, because you know, but they don't know. And now I'm ready to write my system of equations. So the first equation in my system is going to be, you ready? X plus Y equals 2,200. So let's write that. X plus Y equals 2,200. The second equation in my system will be $1.50 X plus 4Y equals 5,050. So I'm going to write that right underneath. $1.50 for every kid added to $4 for every adult makes my grand total money 50-50. So this top equation really has nothing to do with money. This is just number of people. Here's my money equation. And now we can use techniques from earlier in the chapter to solve this system. I'm thinking elimination is going to be best because of the way both equations are in standard form and the x's are stacked, the y's are stacked, and these integers are stacked. So we could either multiply the top equation by negative 1.5 to knock the x's out, or we could multiply the top equation by negative 4. I'm thinking negative 4 is easier to work with because it's not a decimal. So let's go ahead and multiply the top equation by negative 4. When I distribute the negative 4 across the entire equation, I'm going to get negative 4x minus 4y equals negative 8,800. Bottom equation just comes on along for the ride. $1.50x plus 4y equals 50-50. And now I'm going to add straight down. Of course, my y's are going to knock out, so those can go. Now I'm going to take negative 4x plus 150x. So that's going to be negative 250x equals, and now for these two, I might type that in here. I'm going to type in negative 8,800 plus 50-50, negative 3,750. Now to solve for x, I can divide both sides by negative 250, negative 2.50. And so x will be, I'm going to take my last answer here, divided by negative 2.50. And it looks like 1,500. So I was getting close in my guessing. I guessed 1,300 kids. It's really 1,500 kiddos attended the fair. Now it's pretty simple to find the adults. Since I know 1,500 kids attended, if I just go back to this first equation, x plus y has to make 2,200. If I just sub this in for x, I would have right here for this x, 1,500 plus y equals 2,200. And then to solve for y, I'm just going to subtract 1,500 from both sides. And that's going to give me y equals, that should be 700, I believe. 2,200 minus 1,500 should be 700. Ta-da! 700 adults. Check it out. Pretty easy, just using a system of equations. Now, if I just come back one last time to my template here, watch how this works out. With the correct answer in place, we know that 1,500 kids attended and 700 adults. If you add those two together, you most certainly get this guy. Now, let's bring it over to the money. If I take $1.50 times 1,500 kids plus $4 times 700 adults, let's see if we really do get that number. So I'm going to put my calculator up one last time here. So I'm taking $1.50 times 1,500 plus $4 times 700, and I get the magic 50-50. Good job. Okay, we just have one more to do in our notes for today. And if you want to give this one a whirl on your own, feel free. You can always check back and see if you got it right, but I'll be going over this step by step. This one says, Lulu tells her little brother Jack that she is holding 20 coins, all of which are either dimes or quarters. So she's got 20 coins in her pocket, let's say. Some of them are dimes, some of them are quarters. They have a total value of $4.10. She says she will give him the coins if he can tell her how many of each she is holding. Solve this problem for Jack. So 20 coins in her pocket. Add up the money that they make, $4.10. Some are dimes, some are quarters. So let's take a look. I set up another template for some guessing and some checking. Here we go. So, got some dimes in your pocket, got some quarters in your pocket. When you simply add the number of physical coins, silver coins, there's 20 of them. Well, what are they worth? Well, every dime is worth 10 cents a piece. Every quarter is worth 25 cents a piece. When I add it all up, that's the money I gotta make. All right, so granny style, let's just start guessing and checking. All right, how many dimes do we have? All right, let's say we have 4 dimes, which would force us to have 16 quarters, because 4 plus 16 makes 20. Now, if we've got 4 dimes, bring that over here. 16 quarters, bring that over here. Let's see if the money works out. Strictly a guess here. Let's see. So we've got 10 cents times 4 dimes, which would make sense because that means your dimes alone would be worth 40 cents, which makes sense. If you've got 4 dimes, that's 40 cents. Plus, now you've got 16 quarters. So let's take 25 cents a piece times 16 quarters. Enter. Ah, so close. $4.40. Just a little bit off. We're off by 30 cents. That would have to be a frown on my first guess and check. Let's try another one. Let's try to guess and check again. I got a new template here. All right, dimes. Say we've got 14 dimes, which would force us to have 6 quarters. 14 plus 6. Okay, 14 dimes over 6 quarters. Let's see if it works out. Clear that. Okay, 10 cents a piece times 14 dimes plus 25 cents a piece, 6 quarters. Ta-da! Oh, $2.90. That's a nada. That's a big old frown. Oh, I could be here for a while if I keep guessing and checking. I'm an algebra student, so let me use a little bit of algebra on this one. I don't know how many dimes I've got. I'm going to call that X. I don't know how many quarters I've got. I'm going to call that Y. And there's the first equation in my system. X plus Y equals 20. Now, I don't know how many dimes and I don't know how many quarters. Here's the second equation in my system. So let's go back to the note sheet and get this rocking. First thing we'll do, we'll tell our readers what is what. So we're going to let X stand for, or hold the place for, the number of dimes in Lulu's pocket, or her purse, or wherever she has them. I'm saying pocket. And Y is the number of quarters in Lulu's pocket. Now, the first equation in our system is simply that the number of dimes added to the number of quarters has to make 20. And then the money. Every dime, 10 cents. Every quarter, 25 cents. And we make a grand total, $4.10. And this is almost now a replica of our problem above. We are going to use elimination to solve. So, we could either multiply by a negative 0.10 or a negative 0.25. Either one's dealing with a decimal, so why don't we go ahead and multiply by the smaller number, negative 0.10. So I'm going to multiply the top equation by negative 0.10. When I distribute, I'm going to get negative 0.10x minus 0.10y equals negative 2. If you take negative 0.10 times 20, you're going to get negative 2. Now the bottom stays the same. 0.10x plus 0.25y equals 410. Ta-da! Add them together. These, of course, knock out. That's why we eliminate. Now we add these y's together. Negative 0.10y plus 0.25y is going to be a positive 0.15y equals, and then if we take negative 2 plus 4.10, we should get positive 2.10. Now we're going to divide both sides by 0.15. And that I'm going to do on the calculator. So 2.10 divided by 0.15 is 14. 14. Oh, man. Now that's y is quarters, so that's 14 quarters. I almost got that, except when I did my 14 in the guess and check, I think I did 14 dimes. Yes, I did. I knew I used a 14. I just couldn't remember where, but it was the wrong one. If I had reversed those, I would have had it. Okay, so 14 quarters. Hey, that forces, if the total coins is 20 and your y is 14, then x plus 14 has to make 20. So, of course, x has to be 6 dimes. And that's your answer. 6 dimes, 14 quarters. Now we can check it out in the guess and check. If I come back one last time to this guy, so my dimes were 6, put a 6 in here, quarters 14, of course you add those, you get 20. And if I do 6 dimes, 14 quarters, I'll just prove that the money works out here by taking 10 cents times 6, plus 0.25 times 14. Ta-da! $4.10. We've got a winner. Guessing and checking might have taken a little bit too long for my liking, so you see the application of the algebra. And I also want you to know, before we leave this video, I chose on these, just because of the nature of how they were stacked up, to use elimination. You certainly could have used substitution. I don't know if I would have graphed, but substitution would have worked. Like, you could have taken this top equation, maybe solved it for x or y, maybe y. Let's see, you could have done this top as y equals negative x plus 20. That would have been your stuff. And then you could have plugged this stuff in for this y and gone about your merry way solving for x. It's just a matter of what your preference is. My preference for these was elimination. Okay, thanks for watching. Good luck. See you next time.